This example again asks us to solve a cubic equation. Again, the example asks us to use our graphic calculator as an aid to our computation. However, as we're going to see, this problem is going to be quite different from the preceding one, despite the fact that the two look very similar. Once again, please do not forget to exercise yourself in plotting graphs of functions with the device you're going to bring at your exam. So here's approximately what you should get when you plot the function with your graphing device. Okay. Next. It seems that the graph of x cubed minus x squared minus 8x plus 6 intersects the x-axis in 3 points. Here, here, and here. So the graph of our function intersects the x-axis at 3 points. Now, can we eyeball those 3 points? Well, in fact, that's a trick question. Sure, I see the number 3. I see that the graph of the function intersects the x-axis at the number 3. I can see that one. But the other two, I really can't figure them out from the picture. I see that this number here is close to -3, but not exactly equal to -3, and I see that that number there is close to 1, but not exactly equal to 1. So where exactly what are exactly the values of these two numbers? Well, I cannot eyeball them at this resolution, and quite frankly, if you're using a graphing device, you may have difficulty with your graphing device as well. Okay, so it seems that pure guessing here will not quite work. However, we are armed with the technique of polynomial long division, and we remember that we can use polynomial long division to factor polynomials. Let's do exactly that. So in order to find out what are the two roots besides 3, here's what we're going to do. We're going to take the original polynomial x cubed minus x squared minus 8x plus 6, and we're going to divide it by x minus 3. So we guessed that 3 is a root. If 3 is a root of a polynomial, that means that that polynomial is divisible by x minus the root, right? So if 3 is the root x1, then we're guaranteed that x cubed minus x squared minus 8x plus 6 will be divisible by x minus x1, by x minus 3. So if our guess here is correct, we're guaranteed that the original polynomial will be divisible by x minus 3. Now, how will we know whether the dividend is divisible by x minus 3? We will know if the remainder turns out to be 0. If the remainder does not turn out to be 0, that means that our eyes have deceived us and 3 is not a root. However, if our eyes have not deceived us, then dividing that polynomial by x minus 3 should yield us the remainder 0. So our division serves a twofold purpose. First, to verify that our eyes are not deceiving us, and second, to aid us with factoring x cubed minus 8 squared minus 8x plus 6. Alright, now we're heavily trained on polynomial long division. We did that a few examples ago. So I'll proceed relatively quickly. First, identify the leading term in the dividend and the leading term in the divisor. So next, divide the two leading terms. X cubed divided by x equals, I'm sure you guessed it, x squared. Next, multiply x squared by x minus 3 to get, I'm sure you guessed it, x cubed minus 3x squared. Next, subtract the the dividend and the new intermediate to get, I'm sure you guessed it, so minus x squared minus 3x squared equals 2x squared minus 8x plus 6. So 2x squared minus 8x plus 6. Next, identify the leading term in the new intermediate dividend, so 2x squared. Divide 2x squared by x to get, sure you guessed it, 2x. Next, 2x times x minus 3 equals, I'm sure you guessed it, 2x squared minus 6x. Next, subtract 2x squared minus 6x from the intermediate dividend 2x squared minus 8x plus 6 to get negative 8x minus 6x equals negative 2x plus 6. So I'm sure you guessed it, negative 2x plus 6. Finally, take negative 2x divided by x to get, I'm sure you guessed it, negative 2. Negative 2 times x minus 3 equals negative 2x plus 6. Finally, we subtract the remaining two polynomials to get remainder 0. 0 is our remainder. And indeed, the original cubic x cubed minus x squared minus 8x plus 6 is divisible by x minus 3, and x equals 3 is indeed a root of that cubic. Okay, so our quotient is x squared plus 2x minus 2. So, a reminder, this polynomial here is equal to the quotient times the divisor plus the remainder. Right, and the remainder is 0. So that's our remainder here. So x cubed minus x squared minus 8x plus 6 is equal to x minus 3 times x squared plus 2x minus 2 plus 0. Alright. We can remove the plus 0. So we have in fact factored our cubic. Alright. So we know from our cubic factorization that either x minus 3 equals 0, that corresponds of course to x equals 3, or that we are getting x from this equation, x squared plus 2x minus 2 equals 0. So either x is equal to 3, we already knew that, we already eyeballed the solution x equals 3, or x is equal to, now this quadratic here, x squared plus 2x minus 2, does not have any easy solutions. So we're going to use the quadratic formula. The quadratic formula says that this quadratic here yields us two solutions. Minus b plus or minus radical of b squared minus 4ac divided by 2a. So a equals 1. So I'm using the quadratic formula. Here a equals 1. This is my a. Next, b is equal to 2. And finally, c is equal to negative 2. This is my c. So this is a equals 1, b equals 2, and c equals negative 2. So this is b, this is a, and this is c. Okay, just a reminder, our formula for the quadratic equation was x equals negative b plus or minus radical of b squared minus 4ac over 2a. Alright, that's the formula we used above. Alright, now we're ready to simplify. Let's see, we're having negative 2 plus or minus radical of 4 minus minus is plus, so plus 8 divided by 2, so we get minus 2 plus or minus radical of 12 over 2. So we get minus 2 plus or minus radical of 12 over 2. That can be simplified a little bit further. So I can simplify a radical of 12 like this. Radical of 12 equals radical of 4 times 3, which equals radical of 4 times radical of 3, which equals 2 times radical of 3. So radical of 12 I can replace with 2 times radical of 3. So I replaced radical of 12 with 2 times radical of 3. And here, as you can see, I'm having a common factor of 2 which repeats top and bottom. So I can simplify further like this. That I can simplify, I can factor out 2 to get negative 1 plus or minus radical of 3, the whole thing over 2. The 2 cancels top and bottom, and I get negative 1 plus or minus radical of 3. And this is our final solution. So finally we get our final answer: x is equal to 3, or x equals negative 1 minus radical of 3, or x equals negative 1 plus radical of 3. So here are our 3 solutions. Now, as you can see, it wouldn't have been very easy to guess that this number here is exactly equal to negative 1 minus radical of 3. That is not something that I could easily eyeball from the graph of this function. So to recap, in order to solve this problem, we used our graphing device to guess one of the roots. Then we used polynomial division in order to factor the cubic. And finally, we used the quadratic formula with a relatively nasty answer to solve the remaining quadratic after our initial factorization.